We program the iPad and we program the concept of Semaphore IQ for the interlocking, this interlocking that we use to be the safety layer. And so the iPad is a requesting mechanism and a reporting mechanism, but it's the brains, the interlocking, that actually takes those inputs and creates those safety scenarios to validate that what's been requested is fair and fit for purpose and fit to actually execute in the field.
Welcome to the Stantec.io podcast, where we speak to our scientists, designers, engineers, and architects who are combining subject matter expertise with cutting-edge technology to develop digital solutions that can help solve the problems of today and tomorrow. My name is Dave Roberts.
And I'm Mike Arsenault. This month's episode is focused on safety in the rail industry. Trains are essential to global productivity, and safety is critically important to rail travel. Effective operations and maintenance activities make sure that small problems now don't become major issues later. Stantec has developed two products that creatively innovate the train yard movements and maintenance activities that are necessary for safe rail operations. The first is called Semaphore IQ, and we're joined by the creator of Semaphore IQ, Firas Al-Tahan.
Firas is Stantec's rail and transit lead, and he is based in British Columbia in Canada. Welcome to the podcast, Firas.
Thank you. Absolutely delighted to be here. Thank you.
Now, before we get going, the solution itself, I do have a nomenclature question for you because some listeners might be scratching their heads a little bit. What exactly is a semaphore and how does it relate to your digital solution?
Oh, it's a great question. So a semaphore is in essence any kind of apparatus or tool to give a visual signal from one area over a distance. And so the semaphore is an opportunity for us in the railway industry to send a signal or a message from the trackside to a train operator or a driver. And that's one of the reasons why we chose that name, semaphore.
Excellent. So Firas, let's start off by understanding what the key features and capabilities of Semaphore IQ are.
Semaphore IQ is an integrated system made up of commercial off-the-shelf equipment that we integrate towards our client requirements. So it's made up of 3 or 4 foundational parts that come together to meet the demands of a rail control system. We have our trackside elements that manage and to track train movements across a rail geography. We have that subsystem that then communicates to an interlocking, and this interlocking is the brains. The interlocking takes those inputs and determines whether it's safe to move a set of switches or points per the demands and per the conditions that the trackside equipment are recording. Where are the trains? Is it safe for me to move these switches? The key hazard that Semaphore IQ seeks to mitigate is the hazard of throwing switches or points underneath the train. So we use this equipment to validate routes are safe to be set and thrown, switches thrown. And the final key building block is the UI. And the UI, the user interface, is an opportunity for an end user or an operator sat in a control center or a control room, or even a technician who's wandering around in his or her yard. And this user interface that we have is, in essence, an app on an iPad that we have engineered. And so this app resides on an iPad. It could be wirelessly or wired connection, which is able to report to an end user the status of all the wayside equipment, the switches, and the signals that are being shared to drivers or operators from the wayside. Those are the 3 foundational parts. And as I said, we want to make safe and efficient movements across rail yards and facilities. And that's the key design consideration for Semaphore IQ.
Now, the combination of hardware and software is a little bit different from some of our other Stantec.io digital solutions. So what was the reasoning that you decided to make that combination hardware, software, and what challenges did that present?
I mean, fundamentally, as railway signaling engineers, we wanted to be able to control the end-to-end solution. And we have competence and knowledge in the whole area from top to bottom. So not only are we electrical engineers, system safety engineers, signaling engineers, but we're also integrators. And by integrating the solution from end to end, the UI on the iPad, the communication system, the interlocking, and the train detection systems in the form of axle counters in this particular user case, we have control over the whole solution. And we're able to tailor the whole solution based on our experience, our knowledge of the hazards, and our interpretation of what the users request or require. We go to our end users and our clients with our interpretation of the requirements, they validate them, and we're able to bake that into the end solution. I would foresee that nearly every application of Semaphore IQ is going to be custom insofar as we're going to be varying the baseline product to each of the end user's needs. And by taking control of the full vertical slice, we're able to make sure we give the clients what they're after.
That's fantastic. So can you provide some examples of real-world projects where Semaphore IQ has been used successfully?
We have one project, I can't name the client, but we have one project where we have reached massive milestone, 100% design, and we're in the procurement phase right now. The client is in Western Canada, and it's fundamentally for one of the transit operators out here. The role that we have is designer, integrator, overall engineer and integration lead. We are supporting the procurement, we are overseeing the installation, and then we're undertaking testing and commissioning. So we are owning the whole piece apart from construction. We're nearly EPC, but we're not doing the installation. We let contractors manage that on our client's behalf.
I want to dig into the digital component a little bit more because I'm not sure about the both of you, but I tend to have some clumsy fingers when I'm navigating my iPad. So what sparked in my mind for us when you're mentioning that there is the app component for engineers, people working in train yards to navigate Semaphore IQ and the program, is there a fail-safe available so someone doesn't make a inappropriate press or a slide of their finger across the app? How is that needle threaded?
The technical solution relies on this multiple layer that Semaphore IQ brings. The iPad is not a safety device. We're not going to assume that the iPad is making safety critical or safety related decisions. We're going to assume that the human operator or the end user can make problems, can cause scenarios that are unsafe or hazardous. And so we program the iPad and we program the concept of Semaphore IQ for the interlocking, this interlocking that we use to be the safety layer. And so the iPad is a requesting mechanism and a reporting mechanism, but it's the brains, the interlocking, that actually takes those inputs and creates those safety scenarios to validate that what's been requested is fair and fit for purpose and fit to actually execute in the field. And so in the scenario that someone does have fat finger syndrome and they put a wrong request in, the request may well get transmitted, but the interlocking says, no, what you've requested isn't safe. You're going to cause a conflict here. We don't want you to throw switches because we can detect a train is here. We're going to reject your request. And so it's the interlocking that provides that safety layer to protect against the scenario that you've highlighted there. We've also got a lot of protection mechanisms in the field as well. So as part of Semaphore IQ, we have switch position indicators. And so in the field, we actually present the lie of the switches in an indication, a live indication to the operator. And so procedurally, the train operator would be required to put a demand in at the wayside panel. She or he would get an indication from the system that it's a good move and that the system has authorized the operator to take the route, and then the train operator goes. And the switch position indicator adds to that safety layer by presenting to the train operator in LED fashion what the lie of the switch is, or whether you get a red bar. And that red bar is danger. Do not proceed. We don't want you to take this route. So multiple layers of safety, both in the field and also on the iPad app through the interlocking, which is, as I said, the brains and the safety layer of the entire system.
And given some of the sensitivity of the data that you've just been talking about, what measures are in place to protect that data and ensure privacy when using Semaphore IQ?
So cybersecurity is taken very, very seriously in a lot of the solutioning that we've provided. And also, frankly, they're taken very, very, that subject is taken very seriously with our clients too. So all of the safety layer items are hardwire. There's no data transmission over Ethernet in that respect. Once you get outside of the communications that's established between the iPad and the interlocking, everything downstream of the interlocking is hardwire. There is volts, there's amps, there's no packets. And they are control signals or currents, but they're not data. The only area from a cybersecurity perspective that we've been able to highlight is that iPad to the interlocking communications layer. And when we took a look at that, we made the app as simple as possible. We used Apple's Xcode development platform and used as strictly as possible their own libraries to make the application work. And we used that by virtue because they're going to be tested, they're going to be used, they have been published by Apple for use. There's one can perceive there being an extra risk if you bring third-party libraries into your apps because they may not be as rigorously tested. But that's something that we've tried to lean away from because the app's relatively simple. So the communications between the iPad and the interlocking, as I say, is also done through a closed network. We have a fiber link going between the two, and then a media converter to turn that into normal Ethernet, Cat5, Cat6 Ethernet. And so everything's closed off. We have firewalls that's protecting all of the data away from outside of our system. We are a completely closed off system as well. And then we have really interesting requirements from the maintenance group who say, well, how can we download logs? What's the best procedure from a cyber perspective? And we give them secure USB sticks that allow them to use those terminals to download logs in the case of any failures or scenarios like that. So we give them an end-to-end solution that thinks not just of the end design, but also in the maintenance phase, the operations and maintenance phase. I hope that answers the question.
Continuing on that maintenance theme, and we'll get more into train maintenance coming up later in the podcast when we discuss ARI, but how does Semaphore IQ make it easier to maintain for operators in their yards and facilities?
So, I mean, typically control systems for rail switches and what have you are very centralized. And what Semaphore IQ does is it logs every single move or every single state change to the system, be that a detection of a train entering, be that every throw of the switches. We validate and check the communication signals and ensure that we have heartbeats to validate that the communications between iPad and the interlocking and the interlocking to the train detection systems are kept in a good state, but also recorded and logged so that the operator and maintainer is given the opportunity to fault find. Furthermore, we're able to really kind of secure the site for operators and maintainers to do their jobs in the field too. And so we're able to, by way of the remote control function, cease all movement of switches. And what that does is it provides protection to the operators and maintainers to go out there in the field and actually maintain these heavy duty pieces of equipment and safe in the knowledge that they're not going to be thrown underneath them. They'll still take precautions out in the field, but a quick command on the iPad enables the operators to get confirmation that no switches are going to be thrown. And it's a quicker, simpler method to allow them to get more tool time on the switch machines and any of the trackside equipment that requires, their access, their safe access.
That's excellent. So how does Stantec offer support and training for any organizations wanting to adopt Semaphore IQ?
So long story short, we want to establish relationships with our clients, and we really want to get into their heads to determine what their requirements are. And we've been in the game for long enough to understand the basics, but most transit operators, most freight rail operators have their nuances. And we want to sit in front of them and understand how their sites are to be operated. Because an operator can come to us and say, hey, we'd like a control system for a yard. And the first thing we'll say is, well, what are your requirements? And they'll say, oh, well, it's just a yard. We want to be able to protect trains. And we'll say, well, would you mind if we come and observe the yard? Can we come and see it operate? Can we see the heartbeat of your railway? And more often than not, we'll be able to elicit more technical and operating requirements that will be assumed of the system for us to be then to capture into the technical solution. So really, it's getting a feel for the railway, validating what needs to change to that particular client's needs, and then we hold their hands through the design process. And this is exactly what we've done with the first client, because they're new to this. They haven't seen this digital solution in the recent, in their past. And so we recognize that with the adoption of new technology comes a certain level of indigestion. There's a certain friction of adopting new technology. And so we go with them hand in hand, and we're able to support them. And then this first particular client is actually seeking a maintenance contract as well. So they're not only paying us to do the end solution, but they're also looking for a maintenance contract for us to support them through the life of the operating asset. And so we're able to support them way early from feasibility through the design and into the operation and maintenance phase. And it's through building that confidence of the entire user group that you're able to get the results that we're after, frankly. Through this first project, hasn't come as a surprise to me, being 20 years in the railway industry, but to some of the junior engineers, they've been quite surprised by the volume of people who need to know about how this control system is going to work and operate. And so we have to win the hearts and minds of each of those stakeholder groups in order to stand a chance for this really to be adopted by the railway.
Firas, what a great conversation. Thank you very much for taking the time to be with us here today.
Absolutely delighted to be part of this. Thank you so much for having me.
Now, for more information, check out Semaphore IQ on Stantec.com. And we're staying in rail yards for our second product, which aims to revolutionize the train axle replacement process. Stantec's RE is a faster, safer, and more efficient axle replacement process. We're joined by the creator of RE all the way from Brisbane, Australia, Damian Pianta. Damian, welcome to the podcast.
Thanks, Mike. Good to be here.
So Damian, let's start off by getting a bit of an overview of what RE is and how this innovative solution is transforming train axle replacements.
Look, RE is a creation born from necessity, which is typical. We were actually, it initiated from a birthday party. I was at a birthday party of a mate's, and we're chatting with the GM of the rail yard. And they had a problem where they had a backlog of wagons with bad order wheels. And they had no way of speeding up that process. Their existing workshop was their bottleneck. So we said, interesting challenge, my work colleague and I. So we set about over the next few months coming up with ideas of how to change out wheels faster, safer, and more efficient. It's a semi-automatic process that changes out wheels on wagons, rail wagons, and while they stay in line, and they can be loaded, and makes that process a lot simpler for rail yards.
For listeners who may be having a hard time picturing exactly how the RE system works, you can check out our Stantec.io YouTube channel for a great animated visualization of exactly how the RE system works and how it compares to traditional methods. So Damian, for clients, I'm not really seeing a downside whatsoever from them adopting RE. Just curious, how long does it take to install the system and get the client up to speed on how to operate it and keep their mechanics safe?
Look, the benefit of the RE system is it is a prefabricated unit made off-site. So all the lead time occurs off-site. We could install a unit within a week on site. It takes so it's a precast concrete chassis with the mechanism already built into it, approximately 6.5, 7 meters long, 2.5 meters wide, 1.5 meters tall. So that unit then gets placed into the track. That can happen in as little as a week. By the time the track is cut, it's placed in and set, and the ancillary items around it. The whole, for those who haven't seen the webpage animation yet, the whole principle is you've got a main line, the wheel gets taken down into a very shallow pit, sent sideways, traversed sideways, back up onto what we call a little service line. That is where you roll off the bad wheel, roll in the good new axle. It drops down and then plugs back into the underneath of the wagon. So that's how the process occurs. It happens quite quickly, the installation, and training. It's probably about 2 or 3 wheel sets changes, and you're totally competent on the system. Very simple, very understandable as to how, why things happen, and just very robust.
So with safety being such a significant concern in the rail industry, how does RE improve safety for workers during the axle replacement process?
Yes, Dave, the rail cars, big, heavy, and safety is paramount. Things can happen so quickly. So RE concentrates on keeping the wagons at rail level, on rail level. So we don't lift the wagon per se. We take the weight of the wagon and lower the wheel. People don't leave the ground level. They don't go down in the pit for operations or anything like that. The wheel goes down in the pit and then comes up. And the pit for RE is very shallow, so it's not a big hazard. It is barricaded for edge safety, but the whole philosophy is don't lift the wagons off the rail. People can't get underneath lifted or suspended objects, and movements are limited. So that is the benefit for safety for the operators and the rail operator himself for this.
It really is a product that is revolutionizing the axle replacement process. Damian, if you can just expand a little bit more on the current methods and just how much safer and faster ARI makes that process, and get into a little bit of just the time and cost savings that can be possible for clients if they were to install an ARI system in their rail yards.
Yeah, look, the existing systems have been around for a long time, just like the rail and the rolling stock systems. There's three main ways that existing rail facilities change out wheels. One is within a workshop, and they separate wagons individually, jack them up on a 4-post system, and take off the wheels like that. Now, that's a good, safe system, but it does require a whole workshop facility. It's quite a good system for overhauling wagons, but not great for when you're changing out a wheel. It's the equivalent of getting a flat tire on a car and going to your dealership and saying, hang on, get rid of everyone out of the way that's doing major engine rebuilds. I've got a flat tire here. It's a very big inconvenience for a workshop. So facilities currently try to do things in the rail yards and that sort of thing. They use some temporary jacks, which is quite cumbersome. There's safety issues with that when you're jacking off the ballast and out in the rail yards. Other ones put a scissor lift under the middle of a train, under the coupling, and sort of jack it up in the middle. Now that's, again, it's got safety issues. It also has issues that you're contorting wagons in a way that they don't like it from a structural mechanical point of view. So there's a lot of downfalls there. Whereas ARI came along, we started from an absolute bare basic principle that, right, nothing's on the table. Let's think about this from the very start. How would we do it if we've got no restrictions? So the process is quite a quick process as a result. Wheel changes went from 1 hour down to, we believe we could do it in about 10 minutes. Operations actually achieved down to 8 minutes on a full cycle. So massive time saving. The crew size can be as small as 2 or 3 people. And the dollars then that saves both on crew size, time, and just the speed that you can do multiple wagon wheels is incredible. We estimate the site actually paid off the unit within the first 2 to 3 months of operation. So it made a big cost savings for them, huge.
So what impact has ARI had on reducing downtime and mechanical failures for rail operators who have implemented it?
Yes, ARI has grown into something much better than they initially envisaged. Initially, ARI was designed to clear that backlog of bad order cars, which they achieved within the 2 to 3 month period. It was getting that severe that the rail operator had considered buying another rail consist, another train, just to make up for the ones that were out of service. So they achieved that. That was their short-term goal. Medium term is to build up the efficiency of their rail maintenance and let the wagon overhaul workshop do its job, which is a full wagon overhaul. But long-term benefits have been amazing. They have also implemented, in conjunction with this, what's called a bearing acoustic monitoring system. So it's a predictive monitoring system that, instead of waiting to get a failure of a bearing on a rail wheel, they're predicting forward that it will fail, could be a month's time. And the ARI system then allows them to preemptively change that out and get ahead of the failure curve so that they don't have breakdowns on track. So ARI's been able to actually facilitate that, and they're ahead of the curve, and that really makes a step change difference in their business.
Damian, you've mentioned the speed and the efficiency at RE is able to complete all these axle replacements. How often do train axles have to be replaced? If you can just give us an idea or compare it to a regular car when you have to replace the tires on your car, what is the frequency, the volume of replacements that rail yard operators have to undertake with their fleets?
Wheels should last and can very much last in between overhauls, which are around the 18 months to 2 year mark for a wagon overhaul. And they can and should last that long. But we all know everything mechanical has the ability to fail early. So it's picking up those ones that are failing early. So it's not a massive percentage, but it's a very inconvenient scenario when it occurs. It's happening to rail operators out on track, or in our clients' sake now, they're predicting it ahead of the curve. They're picking up those outliers, which are going to be, they're the problem childs of your network. They're the ones that cause the delays that you were not planning. So it allows operators to plan to do their overhauls when they're supposed to on their 18-month, 2-year rotation for the major overhauls. And this picks up those outliers that are an inconvenience to them. So that makes a really big difference, because you've got an entire workshop, and some of these places are quite automated, these workshops that overhaul wagons. But it's an inconvenience and a disruption to that scheduling that depletes the efficiency greatly for those workshops to bring in such a small menial task like this. Some workshops, this could actually be the equivalent of 4 hours of delay in the process as it moves through the multi-stages, because there's a whole wagon that is taking up a space in the process, in the build process of an overhaul, just for one task.
So what's the best way for any interested rail operators or individuals to connect with Stantec to explore the possibility of integrating RE into their operations?
Yes, Dave, the best way to contact us is re@stantec.com. We've got Bill Ward in the US, who's a local contact over there, myself, and we'll then follow up with you as your requirements as a client to RE and how we can work in with your system.
Fantastic. Well, it's been excellent talking with both you and Firas today. Mike and I have certainly learned a lot more about how Stantec is supporting the rail industry with the innovative solutions such as Semaphore IQ and also RE. I'm really looking forward to seeing how these solutions will continue to evolve and the positive impact that we're having for our clients. So thank you once again for being part of the Stantec.io podcast.
Thank you, Dave.
And thank you for listening. Future episodes will continue to explore how digital solutions are shaping our world. In the meantime, you can also visit our website at www.stantec.io for more information.